In this video, we're going to look a little bit at assembly language. The native language that computers speak is machine code. That's a little bit too hard for us as people to understand. So there's something called assembly language, which is just above that. So what I have here is a very simple program, and this program has some issues. So if I look at my main method, I will see that I take as input a possible list of arguments. Now, traditionally in the C programming language, I have a number of arguments that is passed in as argc, and then I have a string array for all of the things that come after. So if I run my program and I say param1, param2, then it would say the count was 2 and display my stuff. It would pass them in as argv1, argv2. So I create a string and I call it local string, and I put the value of main function inside of it. This doesn't do anything. Later, we will see how this is stored in memory, and this will help us locate certain things. I create another local variable that's an integer, and I store the value hex 11223444 inside of it. And then I call a function called function, passing it the first argument that the user passed in on the command line. Then I return 0. So let's have a quick look at function. Function takes one string parameter. It also defines a local string, and it does this to help us out with our identification of different things in memory. We then define another local integer and a string buffer of length 10. So that gives us at most 9 characters plus the null terminating character. And then we perform a stir copy where we take the parameter that was passed in and copy it to local string 2. What's the problem with this? Well, if that string is more than 9 characters long, it's going to overflow. And we'll see what happens to our program if that in fact does occur. And then function returns the value 1. So in order to really see what's going on here, we need to run this in our Immunity debugger. So I'll go ahead and start Immunity, and I can tell it, please open my program. And which program should I open? Not this vuln server. I want to open my overflow. So you'll see right here, I have a program called buffer overflow. Here I have my program that's been opened. This pane on the left will show me my program, its source code that has been disassembled. So in this column here, I see raw machine code, or opcodes as they're sometimes called. So this code tells me, for example, that 55 means please push the EBP register. Push it where? Well, we'll talk about that a bit later. That is one command. And here we have a set of commands, and we also have some addresses. Over here in this window, we have our registers. So we have a register called A, sometimes also known as the accumulator, and we have some others as well. These registers are, in fact, high-speed memory areas inside the CPU itself. Down in this area, we have the memory dump, and over here we have the stack. Now, to run our debugger, if I go here and I scroll down, I see something that starts at 401290, and then it ends at 4012AA. What's in between? There's a push command, a move command, subtraction command, and then my string function. And that is being moved into a location. I also see the value FFEEDDCC. That value is my integer that I had back in my program. So if I look back at my program, you might say, but wasn't this in the reverse order? It was. The reason that this was in a reverse order is that Intel systems use the little endian notation. And what that means is when you have a value that's more than 1 byte, the smaller part comes first. And this is typical among most processors that you'll encounter. Later in this course, we'll talk about some exceptions to that. Here, we are moving the value of 1 into our location, and then we leave. So there's not too much going on here, but you can see what we're doing. Here we have a little bit more code. There's kind of a preamble, if you will, to our program. And there's a couple of standard calls being made. And here we have the main function string, which is being loaded into a certain location. We have an integer value. And then here we are moving more data. We're making a call. Our call is being made to the memory location 401290. Well, that in fact is this location. That's our function call. After that returns, we move 0, we leave, and we return. So if you look at the program again, you will notice that the main function returns 0. And that's what's happening here. We're moving 0 into EAX, we call leave, and then the function returns, which ends the program. We're going to take a brief break, and when we come back, we'll talk a little bit more about assembly language.